Welcome to our lesson on multiplying and dividing rational expressions. We're going to first look at multiplying rational expressions. It's very similar to just multiplying fractions. We're going to multiply the numerators and then the denominators together. But because we're multiplying rational expressions, just like our last lesson, we do need to consider the non-permissible values. So we're going to state for each of these examples what our non-permissible values are. For our first one, we have 2 over 10 times 5d over 2c. So we only have one NPV, and that's going to have to do with the c that's in our denominator. And we can't have c equals 0 because we're going to have a problem with the 0 in the denominator, and it'd be undefined. So our NPV is c equals 0. Remember, when you're stating your NPVs, we state them as the variable equals and then whatever that number is, because we're stating what they are, not what they can't be. So now I'm going to multiply our numerators together. 2 times 5d is 10d. And then for our denominator, we have 10 times 2c, which is 20c. And then we have the 10 and the 20 in common, because those are multiples of 10. So I can divide top and bottom by 10. If I do that, I'm going to be left with d over 2c. For the next example, I'm going to state our NPVs first. Our first one here, in order for x plus 1 to become 0, we would need x equals -1, because -1 plus 1 is 0. Then your other NPV has to do with this 2x, and this denominator would be 0 if x is equal to 0. So those are our two NPVs. Now we can go ahead and simplify our rationals by multiplying. So a quick way to kind of help you simplify less later on is to look diagonally to see what they have in common. The 4x and the 2x have something in common. The x's can cancel out here because x divided by x is 1. Also, 4 divided by 2 is 2. And then if you look diagonally again, there's nothing else for us to simplify. So I'm going to go ahead and multiply our numerators. So 2 times 5 is 10. We can multiply the coefficients. And then I'm going to leave our x plus 3 and x minus 1 alone for now. This is all over 3 times x plus 1 because we already canceled out the 2x. Now what we can do is multiply x plus 3 and x minus 1. That's x times x, x times minus 1, 3 times x, and 3 times minus 1. That's x squared plus 2x minus 3 after you simplify. I'm going to also multiply our denominators as 3 times x and 3 times 1. Lastly, I'm going to distribute the 10 to each of those terms in the brackets. So that's 10x squared plus 20x minus 30 over 3x plus 3. And that's all we can do for that question. For C, before I state the NPVs, I'm going to factor our numerator and our denominator for both our rationals. So in the first fraction, or the first rational in the numerator, we can factor this as a minus 4 and a plus 3, because 4 and 3 is a factor of 12, and -4 plus 3 gives us -1. Then in our denominator, I'm going to use our difference of squares to factor this, because -9 can be achieved by a plus 3 and a minus 3, since the square root of 9 is 3. Now I'm going to move on to the next rational and factor the numerator here. So factors of 3 are 3 and 1. And in order to achieve a -4, I would need a -3 and a -1. And then in our denominator, I can factor out an a, and that's it, because we have a squared minus 4a. Then we'd be left with a minus 4. Before I go ahead and cancel out all of our common terms, I'm going to state the NPVs. So looking at our first rational and its denominator, we're going to have a problem if a is plus or minus 3, because negative 3 plus 3 would be 0, or the other factor, 3 minus 3 would be 0. And then looking at our second rational in the denominator, if a is equal to 0, would have a problem, and also if a is equal to 4. So those are our NPVs. Now I'm going to simplify this by looking diagonally. So a minus 4 is going to cancel with a minus 4. Looking at our other diagonal, a minus 3 will cancel with a minus 3. And then looking at our first rational, we could also cancel a plus 3 top and bottom. And then we're just left with a minus 1 over a, and that is our simplified rational. Moving on to dividing rationals, we're going to use the same rule as dividing fractions, where we will change the division sign to multiplication sign and then flip the second fraction. So I'm going to do that first before I state my NPVs. The first rational you're going to leave alone. Then we're going to change our division to multiplication and then flip the second rational. Okay, now I'm going to state my NPVs. And it looks like we only have one, and that is when n is equal to 0. Now this question is exactly like our multiplying rationals question. So I'm just going to simplify our second rational in the denominator, because this squared is going to affect the 5 and the n. So 5 squared is 25, and n squared is what we have left over. Now I'm going to cancel diagonally. So 6 divided by negative 2 is negative 3. 5 over 25 is the same thing as 1 over 5. And then I'm actually going to write this down so that we have all this together. There's still the n's, but it just looks like a mess if I keep going on, but you certainly can. So you have negative 3 n to the power of 4 by multiplying across. And then in our denominator, we have 5n squared. So the last thing we're going to do is simplify the n to the power of 4 divided by n to the power of 2, which is just going to be left with n squared. Because we're dividing, remember, we have the same base, you subtract the exponents. And this is what we're left over. Let's do 2 more examples. So for this one, same sort of thing. We're going to change this to multiplication, leave the first rational alone, and then flip the second rational. Okay, now I'm going to state my NPVs on the side before I continue. So for our first rational, 3 times 0 would be a problem. And then look at our second rational. We would have a 0 if x is equal to negative 1, because minus 1 plus 1 is 0. Okay, now I'm going to look at seeing if we can cancel anything out. So it looks like I can cancel out x plus 1 diagonally, top and bottom, and same with x. Now we'll multiply across, so 2 times x minus 2 is in our numerator. And also we have 3 times 4, which is 12. Lastly, I can try to simplify our 2 and 12. This would be similar to 1 over 6 if I divided by 2 top and bottom. So we're left with x minus 2 over 6. And our last one here, I'm going to approach it the same way. I'm going to factor the top and bottom. because you have x squared minus 4, this is a difference of squares. So the square root of 4 is 2, so we can achieve an x squared minus 4 with x plus 2 and x minus 2. In our denominator, we can only factor out an x, and we'll be left with x minus 4. Now I'm going to change our division to multiplication, and then I'm just going to rewrite this x squared plus x minus 20, and then I'll factor this afterwards, just so I'm doing this step by step. Remember to always flip the second fraction. I'm going to rewrite our first rational, and then now I'm going to factor the second rational. Okay, so in our numerator, we can achieve a 20 with a 5 and a 4. 5 times 4 is 20. And then to get a positive 1, we need a positive 5 and a negative 4. And the denominator, I'm looking for factors of 6. I'm going to use 3 and 2. And we can get a positive 1 if we had a positive 3 and a negative 2. So now I'm going to state my NPVs. So looking at our first rational, we would have a problem if x is equal to 0, and also when x is equal to 4, because 4 minus 4 is 0. Looking at a second rational in the denominator, for x plus 3, we're going to have a problem when x is equal to negative 3. And then for x minus 2, we'd have a problem when x is equal to 2. So those are our 4 NPVs. Now I'm going to go ahead and simplify. So we can look diagonally to see if we can cancel anything out. We can also just look by the rational as well. So looking at our first rational, I can't cancel anything out by that rational alone, but if I look at it diagonally, I can cancel out x minus 2. Then looking at the other side, I can cancel out x minus 4 and x minus 4 here, and then that's all I can cancel out by the looks of things. So in our numerator, we have x plus 2, x plus 5. In our denominator, we have x times x plus 3. And I'm just going to expand, and then that would be it. So expanding x times x, we got x squared. Then our middle term is 5x plus 2x, which is 7x. And then 2 times 5 is 10. Denominator, x times x is x squared, x times 3 is 3x, and that would be our final rational.